Hey guys, it's just Math, y'all. We are in pre-calculus trigonometry. We are going to go over complex numbers in polar form. This is 7-5. Here we go. Complex numbers in polar form. Complex numbers are in the form of a plus bi, where a and b are real numbers. Remember what I is. I is the square root of -1, and I squared is 1. You should be familiar with complex numbers. You do this every time you take the square root of a negative. So we're going to, for the first time, talk about graphing a complex numbers. Generally, when we came across a complex number and we wanted to graph it, we would say, oh, we can't graph these because we were dealing with x and y. Well, if we change it to a real axis, also known as the a-axis, this is the real one, and change this one to the imaginary axis, then we can graph these using the same tools in our brain as x and y. So 3 plus 4i would be 3 on the real and 4 on the imaginary. There would be 3 plus 4i. And z2, complex numbers are generally called z's. And the second one that we're going to do is -5 minus 2i. That'll be in the third quadrant. -5 on the real and -2 on the imaginary. And z3 would be -1 0i, -1 on the real, and 0. So there is z3, -1 plus 0i. Now, we generally don't write the 0i because all real numbers are technically complex numbers, because the I part would be 0. So that would just be -1 right there. So -1 plus 0i is just -1 on the real axis. So that's how we graph them. You always need to know which quadrant you're in, or if you're on an axis. So there we go. There's graphing. So now we just learned how to take rectangulars, the x's and y's, and turn them into polar form with sines and cosines. Since the complex grid is exactly the same, we can do the same with complex numbers. And we use the same formulas. We just don't have x and y, we have a and b. And we throw that I in there. Don't ever forget your I. So a plus bi is equal to r cosine theta plus I r sine theta, or the more factored out and easier form is r cosine I plus I sine theta. So what we're going to do first is we're just going to plot one, and then we're going to write it in polar form. The reason we plot this is it's important to know where our number is so we can get the angle correctly. So if I'm going to plot -2 and then 2 squares of 3, so that's going to be -2, and then 2 squares of 3 is going to be over here in my second quadrant. That's -2 plus 2i squares of 3. And so when I do my polar form, I need to find my r, and I need to find my theta. And that is why we need to know what quadrant it is. Okay, so my r is going to be, get my color back in there, let's do blue. My r is going to be the square root of -2 squared plus 2 squares of 3 squared. So that's going to be the square root of 4 plus, now 2 squares of 3 squared is going to be 4 times 3, which is 12. So that's going to be 16, which is 4. So my r is 4. And then my theta is going to be the arctan of 2 squares of 3 over 2, -2, which is going to be the arctan of -square root of 3. Okay, now we know this is going to be negative. We know it's in the second quadrant. We know it is a pi over 3. 3. So which pi over 3 is in the second quadrant? That would be 2 pi over 3. So my tangent, my theta, is 2 pi over 3. Now, just for the sake of being a little easier, we are going to do most of ours in degrees. So theta in degrees is 120 degrees, and that's what 2 pi over 3 is. So for this particular, our z in polar form is going to be 4 cosine of 120 plus I sine of 120. That is the problem. That's the polar form of that complex numbers. All right, let's put that. There we go. Okay. Now, once these things are in polar form, we can quickly multiply them easily. And so we have an example here. We have two polar form complex numbers, and it's very simple to multiply them. We literally multiply the r's, so that'll be 28, and then we add the thetas. So that's going to be 15 plus 25, so that'll be 40. And that is why we do this, because that is so much easier than anything else that we can do. So to multiply them, we literally multiply the r's and add the angles. Awesome. Let's check it out. To divide, we divide the r's and we subtract the angles. So here we go. If I want to do z1 divided by z2, I'm going to divide the r's. That 5 divided by 10 is, 50 divided by 10 is 5. And then I'm going to subtract it. It would be cosine of 60 plus I sine of 60. So there it is divided. Now, sometimes they want the answer in rectangular form. Okay, so this is technically polar form. To get the answer in rectangular form, you literally do what it says. You literally replace the cosine of 60 degrees with what the cosine of 60 degree is. The cosine of 60 degrees is 1/2. And the sine of 60 degrees, if you recall, is the square root of 3 over 2. And so to get the rectangular answer, we would have 5 over 2 plus 5 square root of 3 over 2, and then we put our I. This would be in rectangular form. Make sure when you're doing your work that you look to see what form they want their answer in. Polar form is going to be like that one, but if they want it rectangular, then you need to continue on. Let's back up to the previous problem. I'm going to show you. This is the polar form answer. If we wanted to do rectangular, cosine of 40, we would literally use our calculator to do this one, okay, because we can't use, we can't do cosine of 40 on our unit circle. We don't have that one memorized. So make sure your calculator is in degree mode. And once it's in degree mode, you can do this one. You literally do cosine of 40 degrees, which is going to give me 0.766. And then I'm going to do the sine of 40 degrees. And I'm going to get 0.643i. And then I'll multiply both of those by 28. This one's going to give me 17.998i. And the other one is going to give me 21.449. So this would be the rectangular answer. Again, using a calculator to literally do 28 times the cosine 40 and 28 times the raised to a power. Again, we're going to use this new formula. We're going to raise it to the power. This one is actually called de Moivre's theorem, and we're going to use this formula here. I want to raise this one to the third power, so I'm going to do 2 to the third power, and then I'm going to multiply 40 times 3, so that would be cosine of 40 times 3 plus I sine of 40 times 3. Okay, so that's going to give me an 8. That would be cosine 120 plus I sine 120. And this is the polar answer. It tells me to put my answers in rectangular form. So these are degrees. So is 120 on my circle? Yes, 120 is on my unit circle. So I'm going to use exact answers. I'm not going to use my calculator. The cosine of 120 degrees is negative 1/2. The sine of 120 degrees is the square root of 3 over 2. Now I'm going to distribute my 8, so I'm going to get negative 4 plus, and I'm going to get 4 square root of 3i. And so this would be my rectangular answer. Okay, all right. Now, the hard one is the roots. This is the roots. The de Moivre's theorem for the roots, and this is the hardest one. It requires multiple calculations, and so here we go. It says find all the cube roots of 8 cosine 210. Sorry, that was not right. Of 8 210 minus I sine 210. Okay, we have our formula, and so there are 3 of these. It says cube roots. There are 3 of them. So the first one, the second one, and the third one. We have to do 3 calculations. Okay, that's where this K stuff down here is. All right. So since there are 3 of these, the first one comes by just doing the cube root of the 8 plus cosine of the 210. Now technically this is 0. So it would just be 210 times 3. The second one, we're going to add 360 to it. And then the third one, we're going to add 360 again, also known as 720. So that's how we do it. The first one we do as is. The second one, we add the 360 degrees to it. And then the third one, we add 720. And if you keep going, you keep adding another 360. Okay? So that's what this 360K means. All right, so we'll do this one. So the cube root of 8 is 2. Cosine of 210 divided by 3 would be the cosine of 70 plus I sine of 70. Okay, I think the answer stays in this format. If not, I'll pull out my calculator. It does. It stays in this format. So the correct answer says that's it. That's the first one. The second one will have 2. And now we'll do the cosine of 210 plus 360 divided by 3. So that's going to be 190. Is that right? 210 plus 360 equals, divided by 3, 190. Cosine of 190 plus I sine of 190. Again, this is the polar answer. And then one more, which I did not give myself enough room for. Let's see if I can squeeze it in here. Be 2. Ooh, it doesn't like it when I go off the grid. Cosine of 310 plus I sine of 310. Again, this would be the third one. Those are all the cube roots of this complex number. Okay. Finding all the cube roots of I. write your answer in rectangular format. Okay, I'm going to come back and do this one on another video. Give you a break, let you think this through. It's just math, y'all.